Hello and welcome to another episode of Better Together at Science with Shinrai Sensei. And today we're going to talk about the three methods of heat transfer, right? And this is kind of relevant to the atmosphere discussion, and it's a discussion that's not really very often brought up when people talk about things like climate change and how the systems work with climate change, right? So heat transfer methods, there are three, like I said. There's conduction, convection, and radiation, right? And I've kind of simplified the definitions of each one in ways that are easy to understand, right? But conduction is heat transfer through direct contact with solids. So it's not necessarily that it has to be two solids touching each other for it to be conduction. It can be a solid being in contact with a fluid or something like that, that, the fluid is receiving conduction from the solid, right? But when it comes to convection, this is heat transfer through direct contact with fluids. Now, when I say direct contact with fluids, that means that if I have boiling water, right, that technically would be convection because it's through a fluid. The boiling water is the fluid, and if I put something inside of a boiling pot, right, the conduction of the metal to the fluid is creating convection, which will then transfer into like an egg that I boil in the water, right? So if I was to go ahead and draw on this board, let me grab a different colored marker so that it's a little easier. So if I draw on this board, let's say I have a pot and I have like a little flame right here. So we'll draw a little flame. And I have it filled with water. Right? Then I put a little egg in there. Well, from the pot heating up the water here, this is conduction because the pot is a solid surface conducting energy into the fluid. But the fluid heating up the egg is actually convection. Because once again, it's about the fluid heating the egg up. That's the convection. So if the egg is not making direct contact with the bottom of the pot, if it's somehow just floating directly, in the middle of the pot, not touching any of the solid surfaces, it's only receiving the heat from the boiling water, then the boiling water is using convection to heat the egg, whereas it's conduction that heats the water. So the water gets heated through conduction, the egg gets heated through convection, and that's kind of a simple way to demonstrate where these two methods, like what the relationship is in your everyday life, right? So a lot of the time you'll hear about like convection ovens, like the New Wave oven. Jetstreams used to be one of the ovens that they have for that, and a lot of air fryers. They say they're air fryers, but really what they are is more of a convection style oven. And what they do is they heat like a coil at the top or bottom or both, and then they circulate air with a fan throughout the entire mechanism, and then that air will then superheat and cook the food, right? So like if let's say I throw some breaded chicken or I throw some French fries in my air fryer, it works the same way that the New Wave oven would. It's just slightly different design to what it does. And it has a slightly different purpose to what it does, right? A lot of those older convection ovens will only reach like a maximum temperature of 400, whereas some of these air fryers will reach a maximum temperature of 480 or so to try and get something really crisp, right? And that's what air fryers are more. They're more angled towards making food crispy without needing oil, whereas convection ovens are more about baking things. And so you're trying to bake cookies, bake pizza, some of those ovens, you could put a whole turkey breast in there and bake that. And so you have a little bit more of a specific purpose with a convection oven, whereas the air fryer, or I should say they both have specific purposes, right? But they're both convection, and they both use almost the identical method of heat transfer to heat your food up, right? And actually, an oven is a good example of convection at work, because really what you're trying to do in the oven, and if we could find a way to like suspend the food without having to have a rack in there, like without having to have the metal shelf in there or your cookie pan, if you could have it so that you could somehow suspend your cookie dough or your bread dough or your cake batter, if you could suspend that without having to use a dish, we would. And then it would be exclusively heated through convection without any form of conduction being used at all, because it is not in direct contact with any solid surface, right? So conduction is like your frying pans, your pots, all of these getting heated up. The surface of this conducts heat into whatever you're touching. So if I was to throw a burger on a frying pan or a grill, then the grill or the frying pan is going to conduct heat into the burger to cook it. Whereas if I boil pasta or boil the egg, it's convection because the fluid is doing the cooking. Unless it's in direct contact with the bottom of the pot, then it's conduction to some extent. But mostly it's convection because the fluid is doing the heating, whereas conduction is a solid surface is doing the heating. Right? Now for the third form of energy transfer, heat transfer, is radiation. Now radiation, if you know anything about radiation, is it has no required medium. No medium needed because the particles are their own medium. The energy is in the particles themselves, right? So you have photons that come from the sun or come from stars way out millions of light years away. You know, these photons carry the energy themselves. They don't require a medium like air. So my voice going to you, listening to this, and my, you know, any sound that you can think of, that requires a medium, right? So with my voice, I need you to be standing somewhere that has air. If I was to put your phone in a vacuum chamber and suction out all of the air particles that I possibly could with that vacuum chamber, you would not be able to hear me on your phone directly. If you put it on the speaker mode, your phone will make next to no noise, if any noise at all, depending on how few particles or how many particles might remain, because it's really nearly impossible to create a perfect vacuum. So there will be some ability for the energy transfer that sound requires, because sound requires a medium, but the energy transfer will not be as effective because most of the particles that it would transfer the energy through will not be there. So sound needs a medium. Heat needs a medium, unless, in the case of radiation, like we said, the particle is its own medium. So in this case, much like with light energy, right? And the debate that they had, centuries ago now, where they were debating is light a particle or is it a wave, right? Because it functions like a wave, but it also functions like a particle. Particles can travel through voids, and where there's no medium to transfer the particle's energy in that wave format, then light would need to be a particle of its own in order to carry that wave. But it also needs to be a wave because of the electromagnetic spectrum, right? So that's where radiation came in. We started to understand that things like photons are their own, they are carrying energy with them, right? And so photons carry all sorts of different bands of the electromagnetic spectrum's light, right? You have infrared energy is transferred through photons. You have microwave energy transferred through photons. You have X-ray energy transferred through photons. You have gamma rays transferred through photons. Say that 5 times fast. But yeah, radiation is particles energized by a star, and they're usually, going to get that energy from nuclear fusion, and the star ejects those particles out through its normal, processes. It will push those particles out in the form of photons that it emits as light energy, but light energy also has heat energy associated with it. There is no heat without light, and there is no light without heat. So there is no way that you can ever have something be both light and no heat, or vice versa, right? So radiation, the energy is transferred through particles, right? Heat transfer through energized particles. And specifically talking in terms of heat, this is like when the sun beats down on us, it's transferring heat energy through those photons, through the light that we see. We're also getting heat. And that heat heats everything up, creates convection, which causes the wind, causes currents in the ocean, and all that. That's convection. But it also causes, rocks to get hot, and that's where conduction comes in. If you set your hand on top of that rock, it's going to burn you. That's the conduction part, right? But that should pretty well sum up heat transfer methods today. If you guys have any questions, please leave them in the comment section below. I look forward to hearing back from you. Or you can always tag me on something on Twitter or X or whatever they've rebranded it to now. But I look forward to seeing you guys next week. Peace.